the trigonometric functions. For an acute angle theta, the 6 trigonometric functions are defined as ratios of lengths of sides of a right triangle as follows. See figure 6. Angle theta and a right angle. You have the adjacent, the opposite, and hypotenuse equations for returning to the text. Sine of theta equals opposite over hypotenuse. Cosecant theta equals hypotenuse over opposite. Cosine theta equals adjacent over hypotenuse. Secant theta equals hypotenuse over adjacent. Tangent theta equals opposite over adjacent. Cotangent theta equals adjacent over opposite. This definition doesn't apply to obtuse or negative angles. So for a general angle theta in standard position, we let big P of x and y be any point on the terminal side of theta, and we let r be the distance, the absolute value from of OP as in figure 7. See figure 7, sidebar. Point O is the origin, point P of xy. Back to the text. We then define equation 5. Sine theta equals y over r. Cosecant theta equals r over y. Cosine theta equals x over r. Secant theta equals r over x. Tangent theta equals y over x. Cotangent theta equals x over y. Since sidebar, if we put r equals 1 in definition 5 and draw a unit circle with the center origin and the label as theta, as in figure 8, then the coordinates of big P are open cosine and sine, cosine theta and sine theta, close. See figure 8. Big P of cosine theta and sine theta. Figure 8 radius of 1. Cosine is the x and sine theta is the y. Back to the text. Since division by 0 is not defined, tangent theta and secant theta are undefined when x equals 0, and cosecant theta and cotangent theta are undefined when y equals 0. Notice that the definitions in equation 4 and equation 5 are consistent when theta is an acute angle. If theta is a number, the convention is that sine theta means the sine of the angle whose radian measure is theta. For example, the expression sine 3 implies that we are dealing with an angle of 3 radians. When finding a calculator approximation to this number, we must remember to set our calculator in radian mode, and then we obtain sine of 3 is approximately equal to 0.14112. If we want to know the sine of the angle 3 degrees, we would write sine 3 degrees, and with our calculator in degree mode, we find that sine of 3 degrees is approximately equal to 0.05234. The exact trigonometric ratios for certain angles can be read from the triangles in figure 9, for instance. Sine pi over 4 equals 1 over square root of 2. Sine pi over 6 equals 1/2. Sine pi over 3 equals square root of 3 over 2. Cosine pi over 4 equals 1 over square root of 2. Cosine pi over 6 equals square root of 3 over 2. Cosine pi over 3 equals 1/2. Tangent pi over 4 equals 1. Tangent pi over 6 equals 1 over square root of 3. Tangent pi over 3 equals square root of 3. And figure 9, sidebar, you have two triangles. Furthest left is a right triangle where the angles are both pi over 4, and the adjacent and opposite angles are 1, and the hypotenuse is square root of 2. The second triangle is a right triangle where there's an angle pi over 6 and its opposite is 1, and its adjacent is square root of 3, and the other angle that's non-right is pi over 3, and its adjacent is 1 and its opposite is square root of 3, and the hypotenuse is 2. Back to the text. The signs of the trigonometric functions for angles in each of the 4 quadrants can be remembered by means of the rule all students take calculus. Shown in figure 10. Sidebar, figure 10. Top right quadrant, big A, all ratios greater than 0. Top left, big S, sine of theta is greater than 0. Bottom left, quadrant, big T, where tan of theta is greater than 0. And quadrant, the bottom right, is big C, where cosine theta is greater than 0. Back to the text. Example 3. Find the exact trigonometric ratios for theta equals 2 pi over 3. Solution: from figure 11, we see that a point on the terminal line for theta equals 2 pi over 3 is big P, open, -1, and -3, close. Therefore, taking x equals -1, y equals square root of 3, r equals 2. In the definitions of the trigonometric ratios, we have sine of 2 pi over 3 equals the square root of 3 over 2. The cosecant of 2 pi over 3 equals 2 over square root of 3. Cosine 2 pi over 3 equals negative 1/2, and secant 2 pi over 3 equals negative 2. Tangent 2 pi over 3 equals negative square root of 3, and cotangent 2 pi over 3 equals negative equals negative 1 over square root of 3. See figure 11. There's an obtuse angle of 2 pi over 3 that creates a right triangle in the quadrant where sine of theta is greater than 0. Extending from the origin, there is the hypotenuse of the right triangle terminating at point big P, open, negative 1, and square root of 3, close. And the x-axis is negative 1, distance is 1, and square root of 3 is the what if that's the hypotenuse, square root of 3 is the other side of the triangle, and the inside, I guess the opposite of pi over 3, and that's the angle, is square root of 3. Alright, back to the text. The following table gives some values of sine theta and cosine theta found by the method of example 3. There are rows, and 3 rows, one of theta, one of sine theta, one of cosine theta. For sine theta, there's 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 3 pi over 2, 2 pi. And then for sine theta, there's 0, 1/2, 1 over square root of 2, square root of 3 over 2, 1, square root of 3 over 2, 1 over square root of 2, 1/2, 0, negative 1, 0. Cosine theta, 1 square root of 3 over 2, 1 over square root of 2, 1 over 2, 0, negative 1 over 2, negative 1 over square root of 2, negative square root of 3 over 2, negative 1, 0, and 1.